All right. Well, let's get into it. So today is day 6. Hard to believe we're already on the second week of our content here. And we're going to talk a little bit about manipulating data and introduction to one of the coolest topics that can be found with R programming, and that is data visualization. We're going to do a little bit of an intro today before we dive a lot deeper into it tomorrow. And if you're keeping up with the optional homeworks and just the additional problems that are parts of the lab, after today, you should be able to get through most, if not all, of the optional homework 3. So again, those are just for additional practice if you're interested in really honing these skills and just making sure that they're super solid. So that is there for you. Of course, there's the key too if you want to check your answers. All right, so let's get into manipulating data. But before that, let's do a recap of what we learned on Friday, a couple days ago. Hopefully we had a little time to digest. So we talked a lot about missing data and functions from the non-ER package. So there's a bunch of those that can be really helpful, particularly ggmissvar, which creates a really nice plot of missing data, and missvar summary, which can help us determine, in a kind of summary table where we might have missing values. There's some functions which can help you drop missing data or drop columns that have any missing values, such as missvar which. And important to note that filter, remember we learned about filter on subsetting day on day 3, that's going to automatically remove missing values. So it doesn't actually know, say, hey, I want all the data greater than 100. It's not going to know how to treat missing data and how to do a logical test on missing data. So it just drops it when you do a filter step. Drop NA can help you remove NA values manually if you're not using filter. And important to think about the fact that missing values can change your calculation results. So thinking about whether you want to exclude NAs or not should be something that you are thinking about. What do those missing values mean? Why is it missing? Diving into the data dictionary or the data summaries and metadata a little bit more if you need to explore, kind of why that data is missing. And replace NA will replace NA values with a particular value. Maybe you want all of the missing values to be 0 or a different number. That's totally fine as well. We have functions for that. All right. And then some very powerful functions for data cleaning. Kswen is going to help you recode entire values based on some condition. So you can say, hey, when this column equals the number 10, I want it to be, I want it to be called large. And when the value is under 10, I want it to be labeled small, something like that. So you can create new data or new columns based on other ones. We also looked at the stringer package a little bit, which has great functions for doing, replacements of different text, and can also use the separate and unite functions to both split apart and join back together contents from columns if you want to. And definitely check out the cheat sheet from day 5 for a recap of what those functions can do. All right. So manipulating data. In this module, we're going to talk about how to reshape data. And in particular, we're going to go from a wider format to a longer format of data. Not actually changing the data. We're just changing how it's shaped. We'll also do the opposite. We'll go from long format to wide format. And we'll talk a little bit about merging data, sometimes called joins. So we'll get into that in the 3rd session for today. All right. So what is wide or long data? So data is wide or long with respect to certain variables. So if we take a look at this kind of picture right here, maybe you're looking at patients that were exposed to some, environmental pollutant or something like that, and you're measuring them across different days. And so, you could imagine a scenario where each patient has its own line, and then different days are represented by columns, but we might need that actually in different format. And so what we might do is have multiple lines per patient, but one line per day. So that way the days are all put in one column here, and then the measurement or the value is in one column here. So just a different way to depict the data. Notice that the values themselves haven't changed really. Okay, so another way to put this is that data is stored differently in the Tibble. And here's another example. We could maybe say we're going to look at vaccination rates over 3 months in different states. Maybe we're looking at Alabama, and we're looking at rates across different months. So we have June, we have May, we have April, and a different rate of vaccination here. So our wide format might have those months kind of in different columns. And our long format is where the column names have actually become the data itself. So you can see up here, I have the June vaccination rate. And then now June vaccination rate is in the cell here. I've got new column names. I've got a column called name and a column called value. I didn't have anything like that up here. But if I look at the numbers, these are the same. So 0.516, the same as 0.516 here. So again, stored differently. You might also say, okay, well, wide is going to have multiple columns per individual with values spread across multiple columns. And we might have a different line for each ID, or in this case, each state. But long data is going to have multiple rows per observation or per state. And hopefully we have maybe even a single column that contains the values. And so we can look at the different months here represented by name. That's categorical. But then all of my values end up kind of centralized in this one column called value. All right. Sometimes I think it's a little easier to see this visualized, kind of seeing the data move around and, seeing how the data doesn't change really, but the formatting does. So let's take a moment to look at this. We've got values and the column keys. And now those keys and values are stretched out into long format. One more time, we'll look at it. All right. And so you may be wondering, why do we even care about this? It's the same data, right? Does it really matter? Well, I think sometimes it has to do with what works better for us versus for computer or a language like R. And so generally speaking, I think wide tables are a little easier for humans to read. So, having something meaningful for columns and something meaningful for rows is going to be a little easier to kind of target in on the data point that you're interested in, right? You can kind of eye down the list, find the state you're interested in, and then kind of scroll to the right until you find the month that you're interested in. So a little easier for us to read and compare values in the wide table, but the long table is going to be easier for R to make plots and to do analysis. Okay, so I have a categorical variable here, state, a categorical variable here, name, and then all of my numeric values for, the same attribute. They're all a vaccination rate, right? They're all condensed into this one column called value. And so in addition to these two, kind of rationales for going between the two formats, sometimes we just need to kind of move our data around so that, maybe what's a column now, maybe that's not actually what I'm interested in comparing side by side. We'll see a little bit of this in the lab and through some examples, but it's going to help us to go back and forth and change which columns we might be seeing across our data. All right. So luckily, we don't have too many functions to memorize to do this stuff. So we're going to do what's called pivoting using the tidyr package. This is part of tidyverse, so no need to worry about loading something else. But we'll be talking about a function called pivot longer, which is going to take multiple columns into a single or a couple variables where that data is spread out across those rows. And then we'll talk about pivot wider, which is going to take data from long format and make it wide format. It's going to take a variable and spread it out into multiple columns. There's also a command or a function called reshape. And for a while, actually, its documentation said that it was a confusing function. And when the developers say that it is confusing, I feel like maybe that's a little bit of a red flag. But we generally think it's like a little trickier to use. There's nothing wrong with it, but it's a little easier to make a mistake and get errors that are confusing. So we don't really recommend reshape. Nothing wrong with it, but just want to make sure it's working correctly. And if you're, Googling, we 100% recommend if you've got an issue, you can't quite remember something we discussed, or, it's maybe something a little bit more advanced than what we discussed, and you're Googling, trying to figure out a solution to your data problem. You might see old functions gather and spread. And these are just older names for the pivot longer and pivot wider functions. They work very similarly. So you may see those around the internet. All right. So let's talk a little bit about pivot longer, how it works. All right. So we're going to reshape that data from wide to long format. And pivot longer is going to put column data into rows. And so first we want to describe which columns we actually are okay. We want to get rid of these. We want to stuff them into a row. So we're going to need to describe what columns we want to pivot longer. As we've been doing with a lot of stuff, we'll take a data set, we can pipe it into the pivot longer function, and then we'll want to just tell it what columns to pivot. And so let's see an example here. Okay, so here's an example of how that works. Let's say we have that data set from earlier where we are taking the wide data. It's got states, Alabama, Alaska, and I want to kind of pivot these columns into their very own row. So I will take the data set, I'll pipe that into pivot longer, and I'll tell it, okay, I want columns, and the columns that I want to pivot, I just want all of those that end in rate. So June, May, April, all those column names end with rate. We learned with our tidy select helpers that we can do that kind of programmatically here with ends with and rate. And so what that's going to look like once I do the pivoting and assign it to EX or example long, I have a state column. I now have a name column with the different months and a value column. All right, time for our first gut check here. So what does pivot longer do? Does it summarize the data? Does it import the data, or does it reshape data? Great. Yeah, I agree. It's the reshape data. It's not really doing any summarizing. It's definitely not bringing data in. That's usually with read_CSV or something like that. Yeah, it's just changing the way the data looks. Okay, so we saw here a little example where we did pivot longer. I got these new column names called name and value. These are probably about as vague as it gets. So let's see maybe an option where we can use a little bit more specific column names. Luckily, as part of pivot longer, you can also add arguments for what you want those columns to be. So you could say, all right, well, I want names to, which will be the new name for what was once column names. So we had those months, the June, May, April. What do I want that column to be called? And then values to, what do I want the column name to be that is storing the values? So let's see an example of that. So we're going to get newly created column names month and rate, which are importantly, we need to make sure we enclose those in quotation marks. We don't always need quotation marks around the columns when we're picking out what we want to pivot. But when we're giving stuff a new name, we do want to supply those quotes here. So again, yeah, this is helping us be more specific than name and value. Those are pretty vague. And so maybe I want this new column here that was names to be month. And I want that values column to be called rate. And so I take a look down here and see month is a little bit more descriptive, and then rate maybe just a little bit more descriptive than value. All right, so let's play around with an example to get a little bit more practice or see a little bit more of this in action. So we'll take a look at data on nitrate levels in water from Washington. It's reporting the amount of people who were exposed to excess levels of nitrate in the water across, several decades and quarters of the year. And so let's read that data in and then take a quick look at it. So I'll copy the link here and head over to R. Let me create a markdown so that I can, an R markdown, so I can do a little bit of code and actually save it. All right, we're ready to go. So let's called it, I think, wide nitrate. Zoom in just a bit. We're going to read that in using read_CSV, and our file is going to be that URL. Let me make sure I load the tidyverse first. All right, good to go there. And then we will load that data. All right, so let's take a quick look. We could use the head function, or we could just kind of open it up in the viewer by clicking on it. Again, I have multiple years and quarters, so kind of chronological through time. I have this population on sampled column. This is the total pool of people that were sampled. And then the exposure, the number of people exposed to different levels. So here, 0 to 3 nanograms or micrograms, and then 3 to 5. So kind of steadily increasing in the concentration per liter. And then a column with non-detectable. So those are counts of people. All right. So we've got this data. And so let's imagine we want a scenario where we're kind of summarizing the data. Maybe we need it for a report or something like that. And we want to see a proportion of the population that was exposed to different nitrate concentrations. We want something like the concentration category here where we've got different levels, and then a proportion of the population that was exposed. Okay, so here, this is kind of like a little, around 60% or 0.6 proportion, 0.59 proportion that were exposed to this level. And then, pretty small proportions exposed to the higher levels of nitrate. That's good, right? We don't want folks that are exposed to lots of nitrate concentrations here. All right, so that's our mission. How are we going to accomplish this with the data as it is? Okay, so we had a couple extra columns of the data. Maybe we're not really interested in those right now. We could always read the data in and get that data back, but we've got these columns called population exposed to exceedances and then the percent exposed to exceedances. And these measurements are not really something that I'm looking at right now. So I will drop both of these columns. So we'll drop or select against any columns that end in exceedances. So we'll go ahead and take the data and we can pipe that in to select. We want to select against any that end with exceedances. Okay, so what do we have now? So we got rid of a couple columns. Again, those two columns that I didn't need. Let's go ahead and reassign that. So we're just updating our data. If I can spell the object correctly. All right, so just 9 variables now. Okay, all right. So right now I have these exposure levels here kind of in a wide format, right? So those different levels are the column names. And I actually want those in their own column so that I can kind of look down and see the different levels of exposure. And there's going to be multiple lines per year and quarter. So let's go ahead and say, all right, well, I want you to pivot all of those concentration columns, except I want to keep year, quarter, and then the total population. I want to keep that as is. So let's not select those columns. Let's use exclamation point and not select those columns. Everything else will get pivoted. We'll take wide nitrate. We'll pipe that into pivot longer. We'll tell it what we don't want to pivot. We want to keep year. We want to keep quarter. And we want to keep the total populations pop on sampled. We want to keep that as is. And so always a good idea to kind of look at the result of the pivot. Is this what we want? We wanted to keep these 3 columns as is. They look good. I now have name and value column. These were previously those column names. Over here, I had pop 0 to 3. Now pop 0 to 3 is contained within the name column. All right. If that looks how we want, let's go ahead and update the object by reassigning it. Make sure we run that. The dimensions of my data over here are going to change. So as I run that, I now have fewer columns, but I have more observations. So wide to long. And so just as a reminder, those unpivoted columns, year, quarter, and pop on sampled, these have not changed. So I did a pivot longer. Let me actually call this long nitrate instead. So instead of reassigning it, I'm going to give it a new object name. And because I already changed this object, let me start from the beginning. I'm going to run all of this. All right. So now wide nitrate is back what it was. And so when I was kind of thinking about my mission, I wasn't actually as interested in the total number of people exposed. I was interested in a proportion. And so here's a great chance to use what we learned about the mutate function. We're going to create a new column to determine a proportion. So let's do that. And again, here's our data. It looks a little something like this. And so if we're trying to say, okay, well, how many people out of total we want a proportion, we could just divide the value column, the number of people exposed, to the total number that were sampled. So let's do that. Let's take long nitrate and pipe that into the mutate function. And we wanted to call this, so maybe concentration proportion, people exposed to that concentration. You could give it any name you want, really. And we'll take that to be value, or the number of people exposed, over the total that were sampled. All right. So I now have a proportion over here. And if I look at all of them within a year and quarter, hopefully they add up. That proportion adds up to 100. Looks like it roughly will, right? So luckily, most people are exposed to pretty low concentration. There's a little bit up here, but most people are not in a sticky situation, hopefully. I'll go ahead and reassign that, update it. All right. So I should see, if I open up that data, I should see that new column that I just made. Okay. So now that our data is more tidy, we can take those averages a little bit more easily. So thinking about the average proportion exposed by the different exposure groups, we can go ahead and do a group by and a summarize. So grouping by exposure level and then getting the mean. So we'll take long nitrate. We're going to group it by these concentration levels. So we're going to group it by the name column. And grouping doesn't change anything about the data itself, but it's going to change how summarize works, where we get average or mean concentration proportion exposed. And then we can take that to be the mean of the concentration proportion column. All right. So we took a look at all of the data for all of the years and quarters that were measured. And so if we're thinking, well, what's the average portion of people exposed just over all of these time points, looking at non-detectable and then the low exposure, are pretty high. But then we do see some in this 3 to 5 category and a little bit in the 5 to 10, a little bit less in these higher categories. But that way I'd be able to tell, if there is, a largest exposure category overall. Okay. So an example of how we might take pivoting as part of a whole analysis where we're doing summarization, we're doing cleaning, we're doing subsetting. Okay. And so just as a reminder, there's many ways to select the columns that you want to pivot. So remember to check out those tidy select helpers to look at more of those options. All right. So we went into our longer format. We did pivot longer, but how do we do the opposite? How do we do pivot wider? Okay, so we're going to need to tell it what columns that we want to draw values from. So we're going to say, all right, we want names from, and that's going to be those are going to be the names of the columns that we're creating in the data. Values from is going to fill those columns. And so again, looks a little bit like pivot longer, where you're taking the data, you're piping that into the function. You're going to then supply a names from argument and a values from argument. And again, this is going into your wider format, spreading the data out. Okay, so we had this data from a little bit earlier. This is example long data where we had multiple rows per state. If we were to take pivot wider and take the names from the month column, this one right here, and the values from the rate column right here, it's going to stretch those out into the long or the wide format that we saw earlier. So the names from month, notice how they ended up as the column names. Values from rate ended up filling those cells. All right. So let's go back to this nitrate exposure data set. So what if we wanted to make a wide version of this data that displayed this proportion of people exposed with each quarter as a column, right? So previously the concentration were the columns, but maybe now I want quarter 1, quarter 2, 3, and 4. So I can kind of, maybe I'm interested in exploring the differences among the quarters. So let's see if we could do that. Okay, so maybe we drop some columns again that we don't need. We've got long nitrate. Let's take a look one more time. And so concentration proportion, we calculated that using the pop on sampled and the value column. So let's get rid of those two. We'll drop them using the exclamation point to say, I want to select everything but those. Do pop on sampled and value. Okay, so I'd be left with something like this. I feel good about that. Let's reassign to update the object. All right, data looks a little something like this. All right, and now it's time to pivot. So let's take that long data. We'll pipe that in to pivot wider. And we got to tell it, all right, well, what do I want to draw the new column names from? So let's do names from is actually this quarter column. So I want to kind of make a Q1, a Q2, a Q3 column. And then the values, what column are they going to come from? They're actually going to come from this concentration proportion column. All right, so what is this going to look like? All right now, so instead of having a quarter column, I now have different columns for the different quarters here. All right, and so if I wanted to kind of take a peek at different exposure levels and different quarters, I could maybe try to triangulate those values a little easier if I'm just looking at it. All right, and let's reassign that. All right, and again, different columns for different quarters here. Okay. So before we get some practice, let's summarize a little bit. So the tidier package, which comes as part of the tidyverse, is going to help us convert between wide and long data. Pivot longer is going to go from wide to long. And we're going to specify the columns we want to pivot. You can also specify names to and values to for custom naming of the new columns that you're creating. And pivot wider is going to go the other way. So it's going to go from long format to wide format. And we can specify, or we have to specify the names from to determine what those new columns will be, and the values from to determine what values will populate those new cells, those new column cells. All right. So let's get a little bit of practice in lab. Thank you, Elizabeth, for dropping that link. I know we're really excited for data manipulation. Actually, pretty cool. My mind was blown when I learned you could do this in R because doing it in Excel was not fun. Okay, so let's make sure we load tidyverse because pivot longer and pivot wider are part of tidier, which if I scroll all the way up, I can see that that was attached when I loaded the tidyverse. So tidier right here. Good stuff. All right. We're going to want to open the yearly CO2 emissions data set. We'll use read_CSV to read that data in. All right. And we can probably call it like CO2 or something. And we'll want to use read_CSV. So I'll give us a moment to type a little bit of something out. All right. So let's do read_CSV and then supply that link. All right. So check out the data to understand the format. So let's just take a quick peek. So it looks like I have different years as columns. Let's see how far forward we go. Go all the way up to 2014. And then different countries as row names, or this country column as cells here. But basically one country per row. All right. So now the fun stuff. So we'll create a new data set, CO2 long, that does pivot longer on all columns except country. So we want to pivot everything except this country column. I'll give us a moment to maybe look at that, see if we can take any guesses on how that's going to look, just how that's going to look with the code. All right. So let's see what this looks like. So we're creating a new data set that is called CO2 long, and we want to take the old data, so CO2. That data we want to pipe into pivot longer, and we don't want to pivot the country column. So what is this going to look like for us? Okay, we have tons of observations, but basically now I have a ton of entries per country, but each year is on a unique line. I have to scroll down quite a bit to see any values, right? Because a lot of the early years don't have any data. So I got to scroll down to let's see. So for example, for Zimbabwe, didn't get data until 1964. So, we may need to do some data cleaning a little bit later here. All right. So what happens if I had kind of mixed this up and I pivoted country? What happens? All right. So let's take a look. It just appears that I have kind of moved things around a little bit. If I go toward the end, I have name is country and value is just like the country name, right? So this is not quite what I want, right? So I think that a lot of times the pivoting works, even if you've done it kind of weird or maybe not exactly what you want. It works, but it's always a good idea to kind of check that the output is what you want before you move on. And again, this is what I should see. All right. So now that we have CO2 long, let's use that data and filter the country column. So it only includes values from Indonesia and Canada. I'm going to use filter, and we're going to use the in operator. So maybe a little something like this. Give us a moment to play around a little with that. All right. Well, we're thinking super deeply about that and formulating our code. I will be right back. Okay, we're going to have CO2 long, and we're going to take that old data and update it, but we're going to use filter to keep Indonesia and Canada. But any idea what I put for the call name? What should I put there? Got to be one of our columns that we see here. Exactly. Yeah, so we want to say country is in either Indonesia or Canada, right? But we got to combine. We can't just say, one. We have to use both. So we're going to use the combine here. We'll use quotes because it's a text. So it's checking whether the value for country is in this tiny little vector you gave it. Let's try that. All right. Okay. So it looks like I just have Canada and Indonesia. That's promising. All right. So let's do pivot wider to reshape CO2 long that we created and updated up here. We'll use country for the names from argument and value for the values from argument. We'll call this data CO2 wide. So let's maybe give that a shot. All right. So let's reshape with a couple of arguments. So, the names from and the values from. So we're going to reshape CO2 long. We'll pipe that into pivot wider. We'll want the names from, it's like whatever column that I want to use to make my new column names. We'll use country. And then values from could be this value column. All right, so let's see what that looks like. All right, again, lots of missing data, so I'd need to kind of scroll down. Let's go ahead and reassign it and take a look. All right, so there are some values for Canada in the 1780s. Not sure how accurate that is, but it does look like it is the same value for many, many years. So I'd have to kind of look into the accuracy of that. And looks like we have some data for Indonesia starting in 1889. All right. And then finally, using CO2 wide, drop all NA values using drop NA. Reassign to CO2 wide. Let's take the data. We'll pipe that into drop NA. Let me not put the NA in the middle there, like that. All right. So that will make things a little easier to look at. I only have complete years in my data. All right. And just kind of taking a look at the data, looks like emissions for Indonesia are a little bit lower, despite having more people. And a quick note, you can adjust the scientific notation if that is kind of annoying to look at for you. It's harder to make a side-by-side comparison. You could do options. So the larger the number, the more digits it will display before it uses scientific notation. And let's run that one more time. Take a look. All right. All right. So we talked about pivoting, going between the long and the wide format. And now we're going to talk about something really interesting and I think really useful. And that is joining, so combining data sets. And so a nice visualization of kind of what we're going to cover here are these kind of like Venn diagrams here, showing just different strategies you can have for combining data sets. So, one circle is data set 1, and the other circle is data set 2. And then you're deciding, what strategy you want to use to keep or exclude certain data. And so we'll talk more about this in a moment. All right. So we have a few more functions here, pivot wider and pivot longer, gloriously minimal in terms of the number of functions to remember. There's a few more here, but hopefully not too much. All right. So joining using the dplyr package, part of Tidyverse. And we're going to be talking about, merging and joining these data sets together. Usually we're going to be referring to some kind of key variable. This could be like an ID or something like that. You can see more about what types of joining options you have by typing in !join. So pulling up our options and seeing, okay, outer joins, what are inner joins, what are all these different strategies we can have. So more about those there if you're curious. But let's go through some of them right now. These are some that you might encounter or might want to use in your own work. So inner join is only going to keep rows that have an ID match for both X and Y. Full join is going to keep all the data, all rows of X and Y data set 1 and 2. So all rows are kept even if they don't have a match. Left join is going to keep everything from X, or the one on the left side of the comma, even if there are no matches in Y. Right join does the opposite. So it keeps all rows of Y, the data set on the right side, even if there's no match in X. And anti-join is a little funky. It's going to keep all rows in X in that data set 1 that do not have a match, that are missing a match in data set 2 or Y. All right, so let's talk about some simple data here so we can get a little bit of practice. And I'm going to bring these into my environment. All right. So I have data A's and data cold. These are two different data sets that I'm going to play around with. All right. So data A's was going to be our A states. So Alabama and Alaska. This is a data set that has June and May rates. Our data cold data set, it has Maine and Alaska. They're, I guess, a little chillier than some of the other states. Maybe not all the time, but they've got data from April in this data set. And so maybe we want to try to combine these to make a more comprehensive view of both of these data sources. All right, so let's talk inner join here. It has to have a match in both data sets. All right. So you'll see throughout some of these slides that there's a little icon in the bottom right to describe what we're keeping. And so if you can imagine our data A's and our data cold data set as a Venn diagram, we're only keeping the overlap. between the two. And so let's see what inner join looks like of these two data sets. We'll take inner join and we'll do data A's and data cold. So again, only the matches between the two data sets. All right. And let's actually run that one more time just so I can see all the columns. All right. So I only have one line in this new combined data set. And why do I only have one line? Well, if I take a look at these, the only overlapping state that is in both is Alaska, right? So if I were to try to match Maine over here to data A's, I don't actually have any data for Maine in this data set. So it's only going to keep the ID or the state here that is found in both, that middle part of the Venn diagram. But notice I don't have any missing data. That's good. All right. Left join. All right. So again, looking at our Venn diagrams, we've got data A's, data cold. We're going to keep all the matches, but we're also going to keep everything that was on the left-hand side. So what does that look like? Let's change this here to left join. And again, this is left side of the comma. So data A's. All right. So it kept all of the A states and all of the A state data and included even the fact that Alabama didn't have an entry in the data cold data set. That line is still kept, and we just stick an NA in that cell because, again, there's no April data for Alabama. Okay, so just a slightly different strategy, keeping everything on the left and only matches on the right. Okay, and so one thing that may be helpful to you as you're joining your data sets may be a package called TidyLog. This is purely optional, but meant to kind of give you basically a receipt of your join. So give me the ledger. What kind of rows did I drop? What kind of rows did I keep? I want to know all the details. So you can install TidyLog and load it just as you would another package. It is already installed for me, so not too much work I need to do. Let me actually put the right package name. All right. And so if I try to run this again, it's saying, all right, well, there was one row that I kept that was only in data A's. There was one row that was only in data cold, but I'm actually dropping it. So it's showing up in a parentheses. I have one matched row for a total of 2 rows. So again, like a ledger of what's happening. All right, right join. Watch it one more time. I just think these visualizations are really nice because I can explain things in words all I want, but sometimes you need a picture. All right, so everything to the right of the comma, if we're looking at our Venn diagrams, we're keeping everything on the right and matches as well. Let's change this to a right join. All right, so this time we keep Alaska, that has a complete set of data, but we'll also keep Maine, even though it didn't have any data for June and May. So kept that April value though. We can look at our ledger. There was a row found in data A's. We dropped that. The row only found in data cold we kept. And then the matched row we kept as well for a total of 2. And we've got Alaska and Maine, our 2 rows here. All right. So maybe you're wondering, well, why have right and left join? Couldn't I just swap the data sets? Like, isn't this the same as left join data cold, data A's? Isn't that going to give me the same thing? And yes, it does. But the order of the columns is a little bit different. We talked a little bit about select and how, you can reorder things using select, be a little sneaky that way. You can also reorder things with your joins, but just being strategic about whether you use right or left. It doesn't really matter too much. So taking a look at that one and then taking a look at that one, the TidyLog does kind of clutter things up a little bit. So let me move that up a bit. So because it's just going to take whatever columns are in the first data set you provide it. So in this first one, June and May are first, and then down here, April is first. So same data again, but just slightly different order. The rows are slightly different order as well, but the data is the same. All right. So yeah, that's just a kind of recap of that. So switching the arguments. All right. Let's talk about full join. All right. Full join is going to keep everything. So it is the full picture. It is the left side of the Venn diagram. It's the right and it's the matches. So let's look at full join of data A's and data cold. All right. So I kept all 3 states that I see across all the data sets. I have introduced some missing values, but maybe that's okay. But basically, I've kept all the data that was found in both data sets. So if I was ever worried about getting rid of data, full join would be a good option. But you notice I have more data to sift through and make sense of now. So it just really depends on kind of your goal and what you want to do with the data later. Okay, so let's talk a little bit about includes duplicates. This may be something you encounter when you're merging data sets. It's not necessarily a problem, but something we want to kind of know what is happening when we get a message about that. So let's load in again these two data sets. All right, data A's. This time we're talking about state birds. So we've got a wild turkey and willow ptarmigan. Willow ptarmigans are very cute. They have furry feet. And data cold. All right. So we'll notice I still have the same thing as before where I have states, but notice in data cold, I have multiple entries per state, right? Maybe we did a little bit of cleaning where we made this a long form data set instead of wide form. All right. So let's left join data A's and data cold and see what that looks like. All right. So I have two matched rows. It says includes duplicates. What does that mean? All right. Data including the joining column state, but also that column state bird. Some entries have been duplicated. So Alaska and willow ptarmigan are appearing twice in the data set. So again, not necessarily a problem, but where it could become a problem is when you're maybe trying to do a sum across the entire column. Maybe that's not summing what you think it is, right? Because you've duplicated some data at some point. So just keep an eye out for that. If that is going to be a problem, typically for categorical data, I don't usually think that's an issue, but it may end up being something that you don't want. So just keep an eye out for that. It can affect the way you process your data later. Okay, so this is what we mean. Notice that X2 here is duplicated. All right, so you can stop TidyLog by using unload namespace. TidyLog, it does the opposite of loading that package using library. Because this can be a lot of text and maybe that's kind of getting a little annoying, you can unload it if you need to or want to. All right, so by default, when you're doing joins, they're going to use the intersection. So they're going to use any columns that are in common among the two data sets. However, if you want to be specific, you can use the by argument and specify which columns you want to join on. So I could say, all right, well, I want to do a full join by state. It already was doing that, but actually by specifying, it gets rid of this little message right here. If you don't specify, it's going to tell you what it's doing. And sometimes when we're working with data sets, we may not have the key column or like the ID column, basically the state column in these examples, they might not be called the same thing. So one data set might be state uppercase, one data set might be jurisdiction or something like that. And so even though I know the data is kind of referring to the same thing, the column name might be different. And so one option we have is to use the rename function. We could try to clean up the data sets to match each other a little better. Or we could just specify when we do the join, which columns we mean. And so if I'm joining data sets X and Y, I could say by equals, and then provide it this kind of funky notation here. I want to say, all right, what's the column of interest on X, which is going to be called, let's call it A. And then what's the column of interest in Y? It's going to be B. So it's basically telling the join, treat A and B as the same and join based on that. Okay, so I did mention anti-join. This can be kind of useful, especially for diagnosing issues. I think sometimes we're interested in maybe what data is missing from another data set rather than what matches we have. And so one thing we may be interested in is looking for entries that are in data A, but not in data cold. So maybe we're looking for, states where we don't have the vaccine data and we're seeing, okay, well, Alabama is in the data A's data set, but not in the data cold data set. So good to know. And then entries that are in the data cold data set, but they're not in data A's, we could anti-join the cold data set to the data A's data set and see, all right, well, Maine is in data cold, but it's not in data A's. So this could tell us, what are some gaps in our data? If I needed to go check again and see if I actually did have vaccine data for Alabama. After all, I could refer back to the original source maybe. So that can be helpful for diagnosing, maybe missing data or just which entries maybe not matching up with the other data set. All right, our gut check time. So why would we want to use join functions? So any of these that we just talked about. We could combine different data sources. We could connect our markdowns to other files, or using one data source is too easy and we want our analysis fancy. Yeah, I agree. So we're combining different data sources. Sometimes we don't want to keep the data all in one CSV file, and joining is a good way to combine them. However, I do want to point out here, this very bottom one is a little bit like, oh, maybe we need to combine lots of data to make a really rigorous analysis or to do really cool data science. That's not true. We can do really cool stuff with just one data set. The joining is just if that's what we end up with. If we end up with different sources, that this is a good option for us. All right. So to summarize, we can basically use join functions to merge or join data sets together. It's going to assume that all column names that overlap are what we want to join on. So in our examples, we had the state column name, and so it was joining based on that. We can use the by equals and then provide those column names if they happen to differ, or we could rename, we could clean up the data first. Our inner join, we've got data sets X and Y. Inner join is going to keep only rows that match for both data sets. Full join is going to keep all rows. Left join is going to keep all rows of X, or the left-hand side data set. Right join is going to keep all rows of the Y, or right-hand data set. You can use TidyLog for a detailed summary. That's totally optional. And anti-join is going to show you what is only in X. It's missing from Y. And just remember, you can reverse the arguments. So put the Y data set first if you want to figure out what's missing from X and is only found in this Y data set. So yeah, swap the arguments if you want. All right. So we'll get into the second part of the lab, but did want to point out that we have the functions on the cheat sheet, as well as Posit's tidyr and dplyr cheat sheets that are really helpful. They're going to go into more detail, but they have references to pivoting and references to joining on them. All right. So we've got part 2, and we'll play around with this a little bit. All right. Before we jump in too much, how are we feeling? Thumbs up? Head scratching? Okay, we've got 1 thumbs up. I like the surprise face. Hopefully it's good surprise. And, we'll feel a little more comfortable with it with more practice. Alrighty. Well, let's jump into this one. So we'll open up another data set. Remember, we were looking at like CO2 emissions. So now we're going to pull in a very interesting data set about climate change related disasters. So this is something that I used to do a lot of research on, about like droughts and heat waves and things related to climate change. So extreme events, things like that. All right. So let's open up this data set and we'll call it CC. And we're being a little sneaky here. We're going to rename the column instead of having to worry about it later. I did mention that when you do joins, you can specify that in the join, but honestly, I think it's a little easier to rename the column. So let's do that. Create an object CC. We'll read CSV, that climate change disaster URL. All right. So I've got different countries. I've got indicators, emergency events database, kind of a lot of detail here, right? But then different years and then the number of events. And we want to rename this column country to be lowercase. We'll update the object and we'll do the rename function. And let's take a moment to kind of recall how rename works. And so here's a good opportunity to kind of look in the help. And so sometimes the help is a little unhelpful, but I think this is not too bad. It's going to change the name of individual variables using new name equals old name syntax. So we got to have the new name on the left equals old name. So in our example, country lowercase is the new name and country uppercase is the old name. If I double check, looks good. Looks lowercase now. That's what I want. The good thing is if you mix up these arguments, it gives you an error. It tells you the column doesn't exist. So you can usually swap it. All right. So now we want to join the data sets CO2 and CC by country. We're going to keep all rows, even if there is no match. How many rows are there? So keep all rows should tell us we want to do a full join, right? We want to keep everything. Don't get rid of any data. And so let's CO2, I think we made all the way at the very first part. So let's just copy that down here, because why not? And that is, let me put it in the chat too. And then go. So CO2 looks like this. And then we just looked at CC, looks like that. So we're joining on this country column. We're going to try to put emissions data next to climate change disasters data. So let's do full join. We'll do CO2. We'll do CC. And let's do by is country. All right. So it looked like something happened. That's promising. Let's maybe look at it. But I guess how many rows are there? We can just take a peek at this right here. So first value is the number of rows. We'll call it CO2CC. And let's take a look. All right. So country here. Interesting that I have multiple lines for Albania and then Algeria. It could mean something's going on with the way our data set is joining. And so on the left-hand side, we have all the emissions data through all these years, tons of columns. I have 317 columns in this data set. That's quite a lot. Goes all the way up to 2014. And notice that it's added a little dot X onto the end of the column name. So now I'm getting into the columns from the Y data set. And I'm scrolling. Now I see the year .y. So that just is a nice thing that they've tacked on there so I don't get confused and have two columns called the same thing. That's not even really allowed, right? So let's join the data sets again, but we're only going to keep rows that match both data sets. How many rows are there? So basically doing the same thing we just did up here, but this time we'll do only rows that match both. That's going to tell me I want to do an inner join. I want just the overlap in the middle of the Venn diagram. And so when we do an inner join, are we going to have less? We're going to have fewer rows of data? Or are we going to have more rows of data compared to this one here? Yeah, exactly. We're going to have fewer lines of data, right? Because we're only keeping those matches. All right. So let's do inner. Oops. Got to put that up in the chunk. Let's do inner join. We'll do CO2 CC by country once again. And definitely fewer rows, right? So now have 628 rows. So many fewer than before. And let's do a quick look at the data. Yeah. So remember before I had, looks like one line for Afghanistan, but now I don't have that when I did the inner join. So maybe there was a problem with the joining of that data, or maybe that data was missing from one of the data sets. All right. So here's how we can maybe get at the answer to that, maybe, possibly. So let's look at what countries are present in CO2 that are not present in CC. We'll use anti-join. What countries are present in CC that are not present in CO2? So it'll take a moment to do that. All right, let's take a look at this a little bit. So let's do anti-join. We're going to look for info in CO2 that's not present in CC. All right. So interesting. It's finding a couple of these countries that are not listed in the CC data set. If I wanted to be really just looking at those country names, I could do a poll and just take a look at the country values here. So interesting that they wouldn't have data for those. So let's see maybe what an issue might be. So let's look at the opposite. So let's look at data that might be present in CC, but not present in CO2. All right, interesting. So let's maybe narrow this down so it's a little easier to look at. Maybe we'll do whole country, and then looks like I have some repeat values. Let's do distinct. We have to do unique with a vector. Whoops. All right. So looks like if I take a look at just a couple first ones here, it may just be the way that the country was noted, right? So I've got Afghanistan, Islamic Republic of here, but if I go up to the other data set, it doesn't have the end part of that, right? Likewise, it's including American Samoa and another additional suite of places that are not reflected in the climate change data set, or not included in the CO2 or the climate change data set. So yeah, these are those that are in the climate change data set, but not CO2. So this is where, maybe I might want to consider cleaning my data a little bit before doing some joining. So that can help us kind of diagnose maybe some issues with the joining that we might want to think about. Yeah, so unique is going to pull out. So if we've got a vector, so this is a vector here, right? We use pull to kind of extract a column into a vector. Looks a little like that, but I have repeat values. And so unique is just going to pull out if I had something like this and select country. So here I have a Tibble still. I could do distinct on that one and get kind of something really similar.